Hello. Today I will be explaining what total mechanical energy is and its components. Also, I will be talking about how it relates to a real world situation. Total mechanical energy, or TME, is potential energy plus kinetic energy. This is called work. When work is done on an object, its total mechanical energy will remain constant. However, in order to fully understand total mechanical energy, you have to know what potential and kinetic energy are and how to find them. Potential energy is energy that is stored. Kinetic energy is energy of motion. Here's how to find potential energy. The formula for potential energy is gravitational potential energy is equal to mass times gravity times height. Or for short, GPE is equal to mgh. Now for the formula for kinetic energy. Kinetic energy is equal to 1/2 mass times velocity squared. Or you can put it as KE is equal to 1/2 mv squared. I know those two formulas can be confusing and there's a lot of components to it. And you just had a knowledge overload. But just hear me out. Now that you have a general understanding of TME and its components, let's apply it to a real world situation. For instance, an airplane. The mass of the airplane would be 80,000 kilograms. Ooh. During this flight, it has a maximum descent of about 10,600 meters. It can carry about 544 passengers. And I know that a fully developed adult would have a mass of 81 kilograms. With that information above, we can calculate the TME, the GPE, and the velocity throughout the flight. So let's do it. Let's say we want to find the total mechanical energy of a filled plane. We know that the plane can carry 544 passengers. Each passenger weighs about 81 kilograms. And we multiply that and we get about 44,064 as the mass for the the passengers. But we also have to add that to the mass of the plane itself, which would be 80,000 kilograms. When we add those two numbers together, we get 124,064 kilograms. Here's where GPE comes in. We want to find the TME. After we find the GPE, the TME will be equivalent. So we use the number we found here, the total mass for the passengers and the plane itself put together. We put that here. That big number, 124,064, which is the mass, times 10, which is gravity, times 10,600, which is the height. When we put those three numbers together, we get a huge number, which is 13,150,784,000. And since this work is measured in joules, and that is the GPE. But the GPE is also equivalent to the TME. So that number is that number. Okay, now that we know the TME or the GPE, let's find the velocity of the plane, let's say halfway in the air. We take that number, that big number, 13,150,784,000, and we plug it into the kinetic energy formula. We do this because the formula ultimately helps us find the velocity of the plane. So that number is equal to 1/2 times the mass, which we found earlier, which was 124,064 times v squared times half the flight. Half of the flight will be half this number here, which would be 6,575,392,000. Okay, with that, we subtract, this will be plus, okay? We subtract this number here, 6,575,392,000. And what we do on one side, we do to the other. Take away 6,575,392,000. And since it's half of that, we know that it will equal 6,575,392. Wait, 6,572,392,000 equal to 1/2 124,064 v squared I went ahead and done more calculations. So now you wanted to find what 1/2 times 124,064 was. And it came out to be 62,032. Okay, now you have the formula. I went ahead and done more calculations. I multiplied the 1/2 times the 124,064 and I got 62,032. So now I want to divide that number on both sides. This side I will be left with v squared, and this side I'll be left with 106,000. So to get v by itself, we find the square root of v, square root of this number. This would be v, and this number would be 325